All right, let's do a couple more examples here. All right, I'm just going to write this a little bigger. So no parentheses yet, no fractions this time. I do need to get my like terms together. So I'm going to go ahead and bring my x to the left. And again, if I want to, I can put that little line there to help stay organized. So I'm going to subtract 8x from both sides. And I have negative 2x minus 12 is greater than 2. Next, I'm going to get my 12 to the right. So I'm just using my regular solving rules right now. And I have negative 2x is greater than 14. Now, my next step is I have to divide by negative 2 on both sides. And be careful here, when I divide by a negative, I'm going to have to flip that sign. So I get x is less than negative 7. So here's our answer. Again, this is sort of the informal answer. I will say your book tends to like the more formal, so you may see it written like this. Same thing for the other problems too. You may see it more formally written like this for set builder notation. This is really the correct way, but a lot of times we accept this as a shortcut way. And we're just going to go ahead and graph. So I'm going to set up my graph here. I'm reading x is less than negative 7. And again, I can do a quick check to plug in and make sure I have graphed the correct side. All right, let's do one more here. All right, I do have parentheses, so I do have to start there first. So I'm not even going to worry about anything until I clear out those parentheses. So I have 2x minus 6 plus 5x is less than or equal to 8x minus 8, multiplying through. On the left here, notice I do have some like terms, so I'm going to combine those together first, and I get 7x minus 6 is less than or equal to 8x minus 8. Now, I want to mix it up this time. Instead of bringing my x to the left, I'm going to bring it to the right, because I know some students would like to do that. Notice that if we bring the x to the right, I could keep my x positive, which sometimes makes it a little bit easier. I will say though, when you bring your x's to the right, it can be a bit tougher to graph. And I'll show you that in a second. Now I'm going to go ahead and add that 8 to both sides, bring it over with the 6 or negative 6. And I have 2 is less than or equal to x. So again, you can write it like this. Okay. Now my x is on the right here, which is perfectly fine. It is a little harder to graph though. So you want to be careful when you read. This says 2 is smaller or less than or equal to x. So what's happening is the x is bigger than the 2, right? So you want to be careful here. When the x is on the right-hand side, it's harder to understand. It's hard to visualize what we're doing here. So we want our x values to be bigger than 2. So we're actually going to graph to the right here, this way. And I'm going to use a closed circle there on my 2. So when you're reading for the graphing, I suggest reading with the x first. So x is greater than 2, or 2 is less than x. You have to really think about it. If you're having trouble with that, try to get your x's on the left, because it's much more natural for us when the x is on the left with the graphing here. Or you can always switch it around. Just be careful. So if I'm going to switch this around, the little end has to go with the 2 and the open end has to go with the x. Okay, this is not the same as flipping here because of a sign change. This is, I want the same answer. I just need to rewrite it because I'm having a hard time reading it. So when you're doing that, just make sure it stays the same. Little end is with the 2, open end is with the x, and now we can more clearly see that we want the values that are bigger. So my tip when solving inequalities is try to just keep your x's on the left because the graphing becomes much more natural. But if you didn't do it, then just be careful how you read it or switch it around at the end, and that's okay too. Now we do sometimes see these double-sided inequalities. This is actually a type of and inequality, meaning that we need both sides to be true at the same time. And we can solve these actually pretty quickly by working inside to outside. So what's going to happen in these cases is your x is going to be in the middle, and we're going to end up trying to get that x by itself. So I want this x by itself. So think about what you would do first. You would always do your pluses and minuses first, right? So you're going to try to bring this 1 out here, but you have to also do it to both sides. So it has to go to both sides of the equation because we're basically solving two inequalities at the same time. So that plus becomes a minus, and you just want to make sure that you do it in all places. So if it helps you, again, you can draw those vertical lines there. And now we can see that it cancels here, and I'm left with 2x. 3 minus 1 is 2, negative 3 minus 1 is negative 4. So you're still going to add or subtract first to clear out that middle. Now we need to get rid of the 2 here. So I'm going to divide both sides, or all three sides, excuse me, by that 2. And I get x is less than or equal to 1 is less than negative 2. Now, if you did divide by a negative, you would still flip the sign. So if this was a negative 2, then all of these would flip over. Everything flips. So you still have that same rule to watch out for. And when you're graphing something like this, remember these are the ones where x is sandwiched. So on the negative 2, I see an open circle because of the less than. And then on the 1, I see a closed circle because of this equality piece. And then I shade in the middle. So everything in the middle is true. So for example, if you plugged in 0 here, is negative 2 less than 0, which is less than 1? So is 0 in between? Yeah. So we're shading everything in between here. All right, and let's look at an application. So to earn an A in a course, you must have a final average of at least 80%, right? So that would be an A minus. On your first 4 exams, you have grades 86%, 88%, 92%, and 84%. If the final exam counts as 2 grades, what must you earn on the final exam to earn an A in the course? So it's an average, right? So think about this. When we take an average, we add up all our scores and we divide by the total. So far for our scores, we have an 86, we have an 88, we have a 92, and we have an 84. I know the final exam counts as 2 grades. Here's my question. What must you earn on the final? So our goal is to find your score on final to earn an A. So let's let x equal our score on the final exam. But the final exam counts as 2 grades. So we're not going to just add the x to this once. We're actually going to add it twice as part of our average. So all together, I have 1, 2, 3, 4, 5, 6 grades. So there's my average, adding, dividing by the total. Now we want an A, so this has to be at least a 90%. Now this is one of those times where we're not multiplying the percent by anything here because we're just talking about scores. We're not taking 90% of something. So here we're just going to add these all up and see if we can get something greater than 90. So let's see, I'm going to combine my like terms first. So these 4 numbers are going to add up to 350, and then x plus x is 2x. Think about how you can solve here. So this one looks a little bit different, but we do have this big fraction. So we can cancel out this 6 on both sides, and that will cancel out right away. So it's a whole fraction, so the whole thing cancels. So we have 350 plus 2x is greater than or equal, and this is going to be 540. Now we're subtracting 350 from both sides. So I get 2x is greater than or equal to 190. And then finally, I'm dividing by 2. Now 2 is positive, so I don't have to flip anything. And what I get here is 95. So you need at least a 95 to earn an A in class. So that 90% in class. Okay. So just a nice little application there just to kind of wrap up and tie in what we did with the last couple lectures too. So we can apply all of those techniques that we use for strategies with equations for inequalities, as well as a ton of applications with inequalities too.